Today's biggest problems are solved by applying massive computing capability. But how do you ensure a high-performance computer will meet your needs not just today, but for years to come? What differentiates a high-performance computer from a collection of well-proportioned servers? And how do you configure such a system to ensure that users can easily leverage its capabilities without being hindered by the day-to-day issues of system administration and user access? Two people who deal with these challenges on a daily basis are Jordi Blasco, co-founder and CEO, and Dr. Elisabeth Ortega, R&D manager from Do It Now, an organisation that brings together experts from the world of HPC and those who use them to push the boundaries of research. I started by asking Jordi Blasco about the research that is currently ongoing in the fields of artificial intelligence and quantum computing, and the role HPCs play.
So, currently, I think it's fair to say that we are living quite a massive boom in AI. So the thing is that, earlier, few years back, so most of those AI models were able to run in a regular computer. So the memory requirements or the CPU requirements or GPU requirements were relatively modest. Nowadays, we see more and more demand on GPU capability. And this is the current situation. So we see more servers getting populated with a massive amount of GPUs to increase the power to a new limit. But at this stage, so this is still a very early stage. So AI will need to embrace parallelization at some stage, to target much bigger problems. And this will bring new challenges. So this means that AI engineers, AI specialists, they will need to get trained on traditional HPC and MPI communication, parallel programming, and so on, or the other way around. People that are coming from a traditional HPC getting trained in AI technologies, to somehow handle these major and massive problems that we are going to face in the near future. When it comes to quantum, quantum is a fascinating field. So I'm computational physicist. My background is in this area. It means a lot for me and for the company. And quantum technologies, there are plenty of options nowadays, but they different strategies, different physics behind it. But they all have a common thing, and it's that they are not a technology per se. It's not a technology that can run independently. So they rely on HPC to complete to have a complete overview of the computation that you want to do. So nowadays, what we are seeing is that there is a demand on integrating those two worlds, quantum computing and HPC. And this is, for example, what we are doing for Kilimanjaro. It's a quantum computer a company based in Spain. And we are integrating workload manager with the quantum computer that they have alongside with an HPC environment.
That's a great introduction. Now, the term high-performance computer is appearing everywhere, even in automotive. What specifically, for you, differentiates a high-performance computing system from a classic server?
HPC stands for high-performance computing. So it's a way to handle really complex and really big problems. Problems that either do not fit on a regular computer or on a regular server. So no matter how big is the server, it might not be able to fit in there. So the way to handle that is by adding more servers and to have a cross communication between them and parallelize the code, to run at the same time across several servers. So when we talk about an HPC cluster or a supercomputer, it's basically having a lot of those very big servers with a very specialized network where the programs can run simultaneously across all those nodes. So this is basically either the problem does not fit in that single server, or maybe the kind of a simulation that you want to run, it takes too long to get the results in a lifetime, for example, okay, or in a reasonable time. So you want to do a weather forecast, and you want to be a forecast, not a kind of a, historical data, right? So you need to have enough computational power in order to reach to that point and have a very accurate weather forecast. So that goes time sensitive kind of simulations. For example, here that I'm based in Auckland, I'm based in New Zealand. Earthquakes is quite a quite a thing here. The risk of a tsunami is quite high. So if there is an earthquake somewhere in the Pacific, we need to be able to simulate the wave thrown of the tsunami and potentially raise an alert and evacuate the people from the areas that are more prone to the tsunami. Few things like this. Okay, so that's the kind of simulations and the problems that we are targeting with HPC.
So there's a lot of complexity involved that needs to be considered. When academia come to you and say, we need a new HPC for our quantum computing or AI research, how do you guide them to the optimal solution?
Okay, so this is a tricky question. So if that particular institution already have our services, most probably we have a solution that we develop that monitors the job efficiency of the cluster. So we know inside out what this community, the complete community using this HPC cluster, they need. So we identify the trends, we identify the software packages, we understand how those programs are able to scale and the behavior at the end of the day. And knowing that allows us to provide consulting services on top of that, and define what technology is available in the market, run benchmarks, evaluate how those codes, specific codes or strategic codes, will run in those available technologies in the market, and then make an assessment and provide feedback around that. So if they don't have too much visibility on that, then usually we run a series of workshops to identify and discover the needs from the community. So usually it's around some workshops, asking some questions, running a survey, trying to identify what applications they are using the most, and basically trying to extract the data that we usually have on a regular basis when we are providing managed services. So we know how difficult it is for an academic environment. So most of us are coming from this world, from a research and academic environment. And so most of the time, so it's more kind of a procurement side of it, or the finance side of it. So having kind of a regular procurement cycle, it's tricky, it's complicated, and aligning this with the technology, it's extremely complicated. So in terms of a return of investment, so there are some moments that if you buy a cluster or if you buy a technology at that time when you have quite a disruption in terms of technology, it makes a lot of sense, because you will get a more future-proof technology that will last for quite a reasonable amount of years, rather than something that will be obsolete in a matter of a few years. So when you look at this in terms of investment, having someone that can help you with selecting the right technology, identifying and balancing the cluster in a way that your user community will actually use it in the best way possible, it makes a huge difference. And yeah, so investing as well on performance analysis, application tuning, at the end of the day makes also quite a big difference, because you can so the architecture that you have, the solution that you have, will be able to do more in less. So at the end of the day, is what it matters, is what all the institutions, not just academic environments, but all the institutions are looking for.
Let me come to you now, Ellie. We've just heard that projects typically start with a workshop to define the requirements and usage needs. What sort of hardware decisions need to be made to build an HPC?
So to implement an HPC, there are some basic building blocks, and then we can adapt or it's been adapted the number of building blocks and its capabilities to target one solution or the other one. So these building blocks are one or several servers related to store the services. So, for example, the user identification, the cluster manager, the workload manager also, and all the applications. So it will depend on the size and the request of the system of the HPC center. Then we will have also a certain number of compute nodes that are nodes that run faster than the servers and that can be adapted with different chips. All of them contains a CPU, but some of them can be adapted to different technologies, plugging the GPUs, graphical processing units, or another accelerators such as FPGAs and so on. Those nodes are connected via a high performance network called InfiniBand is one of them. And then we need the most important part, that is the entry point for the users. That will be what we call the login node that is connected to a external network or to the VPN of the centers that let the users getting in. So the difference of the usage or numbers of these building blocks, it will depend on the capabilities and the needs of the user.
Of course, processing performance needs a lot of consideration. How do you go about determining how much performance and what type of, for example, GPUs or accelerators will be required?
So it depends on the user needs, as you say, and there is no one for all solution. Yeah, I will put a practical example. When I was doing my PhD in chemistry, I have to model big molecules. I was working with enzymes that are very very big, thousands of atoms, but the compute power that we had at the moment was not that big. And the software that I was using for that moment was unable to scale up to 16 cores. That now is, I can run this software in my laptop now. So for the moment, the best SPC that I can use is one where there are different separate nodes of 16 cores, because all the memory will be inside the same machine and the calculation will be as fast as they can. Because if we put another 16, the program will say, "I know I will not use that 16 because I'm targeting to this 16." Now the thing changed quite a lot. And for example, for big projects for AI, you can imagine how big can be the data centers. For example, to train the model of OpenAI to use ChatGPT. So yeah, we have to find why what is the resources that the user needs, and to do so, we have a tool that we develop in Duality now, eh, for the is for the monitoring of the software that is running in the cluster. So what we do is they have their own cluster, or we take some cloud resource in there. We run the workloads that they want to use. For example, I want to use this software, and then we find if this software is escalating as we expect. And then with that, we can say, okay, we have these performance issues here, but it's done by the software, but it's done by the hardware, let's say. And this is how we do it to provide the best tailored solution to our customers.
So we've got a sort of simulation environment where we assess the user's hardware needs. The next important element is software, some of which I assume is a generic base needed to run an HPC.
For this one, there is some software that we are using and implementing. For the login node specifically, we are collaborating with the University of Ohio in the project called Open on Demand. This solution, what it does is lowers the barrier to the entry of HPC by removing the black screen with white letters that we are seeing when we were doing the PhD or our first steps in HPC by a web application with big buttons with all the applications that we want to run there. So the user doesn't have to remember which command they have to type to use their own favorite software, because they will have a shortcut in the web application that they can click and use it.
Clearly, these are very complex systems that can only deliver if they are then optimized to the workloads being tackled. How do you help users get the most out of the HPC they've installed in the area of research they operate in?
So for doing that, we have two stages. The first one is when the previous teams, operations teams and the applications teams, finish the installation of the cluster and the applications, we do a training on the tools that we already installed to them. So we train them to use the workload manager, we train to use how to create new users, how to manage the cluster, and then we can show them how to use certain applications as the a third of the members of Duet in our Spain, we hold a PhD in different scientific applications. So we know what our users are doing. So, and then after we finish this training, we have a dedicated HPC support team that our customers can ask them whatever question that they have, are required to, from the most small one saying, I cannot enter to my cluster, oh, you forgot your password, to the most tricky one when someone can send a huge workload and we are seeing how the cluster is struggling and how to fix that thing. But yeah, we have a fantastic HPC support team in the company.
I imagine it's fascinating for someone like yourself, Ellie, with access to the cutting edge of research into AI and quantum computing. What technologies do you think will fundamentally reshape industry and daily life in the next 5 years?
We already discussed about AI and quantum, so this is you ask to everywhere, everyone, they will see a 50-50 AI and quantum of that. So we already talked about that, so we'll move to other topics. We also commented the one that is, for me, is the most important, that is the democratization of HPC. Using tools like Open on Demand that I just commented before, that lowers the barrier to HPC accessibility. So the future of HPC will not be, or maybe yes, very fast and very big and very capable HPC systems. So there will be a huge community using them, having every day more users taking the advantage of HPC workloads. Then another aspect that I say that I think that will revolutionize the HPC and AI workloads will be the distributed storage systems. So you can imagine, I just commented the OpenAI model, the most famous nowadays, the amount of gigabytes, terabytes, petabytes of memory of this that should be running there. There are already some useful tools that can manage that, but as we are creating every time more and more information, we should think in new ways to work on this storage. And last but not least, I want to miss the point to talk about exascale HPC systems. So nowadays, the company is involved in a project called Multi-Xscale. It's a center of excellence for the Euro HPC young undertaking. There, what we are doing is applying 3 different use cases. One is for precision medicine, another one is for study of batteries, and another one is for the study of the fluid dynamics of helicopter helix. But the thing is not targeting this specific case, is how we took the codes that run these 3 examples at different scales, running the first draft of the simulation in the laptop and being able to move it to exascale computers, so the most powerful computers in the world. To do that, we are involved in a project called EASY, the European Environment for Scientific Software Installations, that is founded by Multiscale. And this is a sort of Netflix for scientific applications. So let's see that a company or a specific center facility or institute say, okay, I want to use EASY, then there is a prior very small configuration at the beginning to use it. But when the user has that in their HPC, with using a single command very, very fast, you can get the specific binary that you need without the need of spending hours and hours compiling it for the specific architecture. And it's not using containers, it's using real binaries architected for the system that you have. This solution, as you can imagine, is quite innovative and quite promising, and it received past November an award from HPC Wire journal for the best HPC technology.
Many people would be surprised, I think, to learn that someone who did a chemistry PhD is now working at a company focused on HPCs. What's it like working at Do It Now?
Our foundation stone for the company, for all that we do now, is the trust. The trust is a must and is going vertically up and down. So from the managers to the workers, workers to managers. So it gives you an extra boost of self-confidence when you are facing challenging projects, because you can imagine if they put me in that project, that means that they believe in myself, that I can do that. So, and then the complexity and the size of the new project that we are arriving with these five countries company that we have, encourage you to give your best. So it's just a push from the ambient. You are talking with your friend, with a coworker, saying the project that they are there, and they say, "Oh, I like it. Let me know how it goes." So, and then the relationship that we have with the members is very, very good. We are working in a hybrid model. So, and also we are spread around the world. Sometimes having a coffee with someone from New Zealand, it's a little bit difficult, but then they can have the tea before going to bed, and we can have the coffee in the early morning, talking about how it was the weekend. And this is something that is it's very, very good to keep a good mood in the company.
And what was it like transitioning to become an HPC expert and learning everything required to advise on how best to tackle complex simulations?
That's a very fun story. You already know. So I started to use the HPC resources when I was doing the PhD, I just say. But when we are doing the PhD, there's something that is called a scholarship that ends and the money stops. So when I had to still finish in the writing of the thesis, and then I was offered to work as system administrator in the same group where I was doing the PhD. So I accepted. I spent 1 year doing that. And in this moment, my group was one of the first customers of Do It Now Spain, that was formerly called HPC Now. It was 11 years ago. So it was some time from now. Then, after finishing my PhD, I say, okay, I want to try this chemistry thing. We left the HPC administrator, and I was working for 7 years as a software engineer and product owner for scientific software applications targeting chemistry. But then I have this feeling that I was missing something, and then I had to come back to HPC. So I got make the interview in HPC now Do It in Spain. I get hired at HPC support technician, but the interest that I have in new technologies such as quantum computing pushed me to lead the R&D and I department.
Jordi, it must be satisfying as co-founder to hear Ellie's story. I guess you have a similar story about how Do It Now came into being.
Yes, so actually, the Ellie's story, it's kind of intervened with the HPC Now story, because well, back in the time, so my background is in computational physics, and I think that when I was still a student at the uni, I met David, one of the other one of the other co-founders of HPC Now at the time, and we started to work together in another working scholarship at the uni for the chemistry department, which was just next on the next building of physics. With the time, I got an opportunity to work in the supercomputing center of Catalonia. Then I went back kind of for the same people that offered me the first working scholarship, working for was around 13 different institutions, 13 different supercomputing centers across Catalonia, all related to computational chemistry. And one of those centers was the University Autónoma of Barcelona, which was the place where Ellie was working on, and she was the she took the job that the previous guy that I was working with was dealing with the cluster administration in that place. So we had quite a ongoing relationship before all this happened, I believe. So this is this is a bit of the close of the cycle.
That's great. Now, for those who are listening to this conversation and are excited by this area of cutting edge technology, what are the technical and soft skills you look for in a potential new hire?
I think that, well, is what Eli said. So the main skill in doing now is trust. So it's the most important one. So trust, being proactive, everything else will follow. That's basically it. So we put all the trust in people. Obviously, in addition to that, we put all the resources that the people need in order to get success on those projects, obviously. But most of us work remotely or part-time remotely. So large part of the team is working from home or from a co-working space or from so we have an office in different locations. We have in Montpellier, in Barcelona, in Torino, in Oakland. But most of the time, those offices are not full. So even if they live in the same city, they prefer to work from home because it gives you more freedom. So in addition to work remotely, we also offer flexible working hours. We trust people. I think that so it's the time that those times where people get pushed on working for several hours until you become kind of a slave. It's gone. And when you are dealing with a very smart, brilliant people, your creativity comes in a obscure and unexpected time, and so this is the magic around that. So it's part of the company culture. So I didn't mention any technical skills, but so obviously if we hire somebody very senior, we want to see real life skills in high performance computing, AI, or quantum. Okay, but for people getting started, you need it's very basic Linux command line interface experience and being a person that we can trust. So everything else, as I said, follows. And so if you don't have the skills, so this is an amazing place for people to learn. Actually, HPC, it's like that. So it's a kind of a field that it's so if you like to interact with the new technologies, if you like to learn new things, new stuff, to be working with bleeding edge technologies. So you never stop learning. So this is part of the duty. So it doesn't matter how much knowledge you come with. You will need to still learn and teach other people in the team. This is part of the magic of the company and this field, obviously.
Well, it's been great to get into the ethos of Do It Now and your openness to accept people from many different backgrounds, potentially helping them to build up the necessary technical skills when the soft skills are a good match. Are there any specific positions open within the team at the moment?
I believe we have like 4 positions open, but those are not restricted to those positions. So we have a open application process. So if you feel like you want to try, you want to learn how it's working in Do It Now, so you can just submit your CV. We are going to review it, and once we have an opportunity, we will call you. So this is easy as that. So we are growing. We are very lucky, and we are growing a lot. We have every day more and more demand. All the processes that we have are extremely interesting, and we have always an opportunity to find some new talent to join our team.
Thanks to Jordi Blasco and Dr. Elisabeth Ortega for sharing their insights around HPCs for research projects into artificial intelligence and quantum computing. If you'd like to know more about them or would like to consider applying for a role, simply search for Do It Now online or on LinkedIn. This interview was created as part of the HiPEAC conference that took place in Barcelona, Spain in January of 2025. To learn more, drop by the website hipeac.net/conference for further information about this premier European forum for experts in computing systems.